I'm Ryan Grant from Digital Contract Design, and I'm giving a talk on how self-custody can be improved by a web of trust, and how the most important aspects of that are key distribution, and how one of the most important aspects of key distribution is key maintenance. And we'll start with some definitions. So rotation is when you have key A and you want to get to key B, and there's some process that you can invoke with your contacts to get from A to B. Recovery is when you had key A and you lost it completely, dropped in a lake, and now you want to get to key B, and again you use some kind of rotation, but you don't have key A to sign anymore, and that procedure is going to be a little different. In revocation, you had key A and you got cracked, and now you have to revoke that key. And you can't necessarily sign with key A. Maybe it's also lost, the equivalent of being in a lake. Maybe it was deleted. But again, you have some process that you can use to revoke. These concepts are not all we have an audience comment that the scary one is when the hacker does an A to B, and that is scary. For definitional purposes, I don't have a different name for that. So, I mean, you could call it a moment where you can't properly do a recovery. It is still possible to have catastrophic things happen if your procedures aren't sufficiently robust. Now I'd like to talk more about the goals. So you want self-custody. Maybe that's why you're here at this talk. And you want an inheritance plan. You're not completely satisfied with just the rogue Bitcoiner with a metal plate of seed words. So the thesis here is that in order to get the best self-custody and the best digital security, you care about other people's ease of use, because you want to bring them into your fold, your recovery plans, your rotation plans. And you want them to help you through their own use of their technology and their ability to maintain safe keys. Okay, so there's about 5 key problems in Bitcoin. You don't want wrench attacks. You don't want government attacks. 6102 is the day they said everybody has to turn in their gold. That's 1934. You don't want single point of failures that you can get from certain trusted hardware or from, let's say, seed words that are the old style stuff. And when you think through these, you're going to arrive at multi-sig. And you're going to realize that you need more than one signature. That's going to give you some geographic distribution. That's going to give you some other robustness that you've heard about a lot in Bitcoin. And if you really take this far enough, you'll also arrive at spending rules where you don't have the ability to satisfy a wrench attack. And this is not very talked about in Bitcoin. It's currently the belief that that's hard to defend against. But I think if there were very public ways to have spending rules, it would reduce the motivation of violent wrench attackers. In the same way that time lock vaults have been used for ages in actual bank vaults. And I think if you're going to arrive at multisig, you're going to arrive at social key recovery as well. That means when you drop your phone in a lake, the other people are going to help you recover your entire system. And so you're going to give them enough permissions to help you, maybe along with other techniques that you're using. So the 5 key problems, you've heard about some of these. I just mentioned everything except betrayal and chaos. Betrayal is the reason you want self-custody. That is your Mt. Gox attack. Chaos is you picked a 25th seed word and you forgot it, or you buried something and it didn't go well, or your house burned down, or something like that. What people can handle in MeetSpace is rather limited, and if you understand this key set of things, you can design a better custody protocol. There's something you know, something you have, and something you are. That's almost it. Except for one thing, someone who knows you. And these first 3, something you know, something you have, and something you are, this is kind of deep in the lore of computer security. And this someone who knows you is newer, and the consequences of that are not entirely explored, because for a long time, keys didn't seem to be valuable enough, right? It was just a matter of whether you could maintain enough security to have a good build for your software. And that was like the most important thing you could use a key for, or a signing ceremony for domain names. There's one more thing that we have in Bitcoin. We have time delay. And there are other possibilities that you can build with those 5 elements. Okay, so we're in the business then of using protocol design to get a good custody result. And things like the trusted enclave or the trusted execution environment on your phone, those can be used. I said you don't want to trust the hardware, you don't want a single point of failure, but if it's one component in your system, it's something that people put a lot of work into, and it's hard to hack, and that can be an advantage. One of the problems that we have is that intrusion detection is a knowledge problem. You don't know when that computer isn't doing what you think it should be doing. That's very difficult to work around, and it's one reason that you want multiple parties and multiple machines. And I've been talking about MeetSpace here. If you think about managing multiple machines, this is not something that's easy for one person to do alone. You're going to leave your house. You're going to leave your place of work. Are you going to take all those machines with you? What does it mean to take them with you? What got left behind? What aspects that were left behind could be used to infiltrate or exfiltrate information? Another thing we have is Shamir's secret sharing. This is the mathematical protocol for turning one key into a set of shards where you can recover them using M of n, or K of n, as is often said these days. And again, this is about things you have your web of trust. Okay, so key distribution is now a big problem you have. If you're going to try and solve things using this web of trust as a low layer in the design of your system. Key distribution is a classic, not theoretically hard, but kind of hard problem. Theoretically, all you have to do is move something from point A to point B in a secure way. But in a practical sense, you have to deal with revocation, recovery, and rotation. And that means some kind of constant flow of information. So we ask, how do you communicate shards? And now I'm going to do a short digression on PGP. I think for a long time, Bitcoiners figured, well, we've got PGP, so this is kind of solved. And it's important to say what's new and exciting that we can improve upon for someone who is already comfortable with PGP. And the answer is based on key revocation. PGP says, first of all, if you need to rotate your key, you should be able to sign it with the previous key, and then you can send messages and people can figure out what to do, and it's all kind of human. Like the humans decide, yeah, that was good enough, and we'll do that. And so there's like decision and subjective experience that makes it a little messy. And then for something as important as revocation, PGP says, well, there's this set of servers and you can go find them, but they turn out to be very centralized. So that how to improve on that is the question that started the decentralized identity movement and decentralized identifiers, which were brought through a standardization process. That standardization process was through the W3C, and this standard that resulted is called the Decentralized Identifiers standard, and it uses separate decentralized identifier methods, one of which I'm going to introduce here as BTCR2, which is based on anchoring things to the Bitcoin blockchain. So you want the self-custody tools of Bitcoin, especially if you're trying to secure your Bitcoins. Your web of trust needs to have a similar level of security. You have a lot of proof of work, anchoring things, we can use that. You've got a lot of censorship resistance built into the Bitcoin network, we can utilize that. And you've got a lot of options in custody design built into the script system of Bitcoin, and we can use that. So the way BTCR2 works, very briefly, is that you declare what addresses on the Bitcoin blockchain you are going to use to announce updates to your DID. And in order to prove that spends of those and then you prove that spends of those addresses either included or did not include a specific update to your DID. There are several variants built into the BTCR2 specification that help you with different scalability options. So you can join with other people to not pay a transaction fee for every separate DID. And you can also break from that set of cohorts to do your own transaction in order to stay censorship resistant. And you can do this publicly so that you can have a public identifier that reveals aspects of some aspect of your life that you want to share with people and have them be able to track, maybe in a professional setting. And BTCR2 also allows you to create private DIDs where the public can't see the updates and can't see what the current DID document is showing. Okay, looks like I covered part of that. I'd like to cover one more thing about decentralized identifiers. The specification is built on a core concept of a document that helps you declare your key material and your endpoints. This is the root thing that you're updating when you update the identifier. So that's how you change the key material. And then that's also how you can attach different keys to change the DID from the keys that you use to make the on-chain update. So you have some keys for liveness and some kind of colder keys to prevent anything from being taken over within the DID document. Okay. In order to achieve better scaling, it's necessary to have a shared UTXO. And shared UTXOs are not very widely used right now. And the number of cohorts in a shared UTXO is not as big as it would need to be for a decentralized identifier scheme on the Bitcoin blockchain to be scalable. And so one of the things that BTCR2 is doing is it's putting forward a very clear use case for shared UTXOs and asking, how are we going to do this? One answer is MUSIC2, and that's one of the answers that we build. We built examples of that into our specification. It's not required to use in order to use a BTCR2 DID, but it is tested and pretty well explained. There are other techniques that can be used. One such technique is to have a K of n cohort assigned to move the transaction forward, and then if n minus k are not participating in moving the transaction forward, perhaps they still have a way to submit an update along with that transaction, or perhaps the K of n have a way to eject participants who are not interactive at the moment, who are not online. And these techniques require tree designs. So some of this is doable in Taproot, but some of it's doable with pre-signed transactions. Those things are better done with opctv because you can, in opctv, you don't have to hold on to as much intermediate data because you can regenerate the tree of transactions. Okay, So there's a lot of work there, and I want to talk to people about shared UTXOs and improving this aspect. I'd like to talk okay, sure. So a UTXO, in very short, is kind of a Bitcoin. What Bitcoin does with transactions is you have Bitcoins and you melt them into this crucible in a transaction, and then you declare what the outputs are. And you basically pick the sizes of the outputs as if you were picking different size gold coins. So you take gold coins of the various sizes, throw them in the crucible, melt them down, and you get different size gold coins out as you specify. The reason it's called a UTXO is it's an unspent transaction output. So when you melt the crucible and you pick the coins that result, each of those is a transaction output. And every transaction output that is not spent, that has not been melted down, is tracked in the UTXO set in Bitcoin. So that's, in short, what a UTXO is. And a UTXO is the thing that you prove control over when you sign Bitcoin to someone else. And so it's always the case that it's always the case that the transaction melts everything into one pool, and it's not the case that something is debited a certain amount and something else is debited a different amount. They are all completely discarded when they melt in the crucible. So there's UTXO. So a shared UTXO then is a situation where I put my coins in the crucible and someone else also puts their coins into the crucible. And the reason this is important is that Bitcoin can only deal with several thousand crucibles melting down coins every 10 minutes in a block. That is the bottleneck. And in order to get past the bottleneck, you have to either not hit the chain at all or work with other people in a way that, using various multi-sig techniques, you can provably share these crucibles in a safe way, and what comes out is the right amount for you to the outputs you designated. Maybe a change and a spend, and the same for other people. CoinJoin is a large network and marketplace of shared UTXOs, and it's interesting, important, and what I'd like to propose is that BTCR2 can deal with an order of magnitude higher scaling, or it should be able to, because the set of people who need the service, or who are aware they need the service, should be much higher. So to go on for a moment about Nostr, Bitcoiners like Nostr as a Bitcoin-compatible social network, but Nostr does not have a way to do key rotation. The Nostr theory is you protect your private key. And in order for Nostr to have more technical options for key rotation, it would have to deal with a plain public key and a kind of new identifier that you can rotate. So that's an ask to the Nostr community, and I'd like to talk with people about that. Can new ideas fit if they require this much more code? Okay, so lastly, we're hiring. We work remotely and we program in Rust and C++. And we've got a couple other languages, but Rust and C++ are the ones I want to focus on hiring right now. And the BTCR2 spec is in a few different places. One of them is btcr2.dev, and the other one is here at GitHub. And with that, I've got 4 minutes for questions.
The question on Nostr, it seems like there was some oomph behind it. Would you say that's some of the motivation, or do you genuinely like the idea? And I know you said you're interested in having those conversations, but what conversations actually have you had so far that was cool?
So far, I've been trying to read NIPs, and as far as compatibility, I think Nostr is extremely compatible with these ideas of building your own web of trust. I think the hurdle there is deployed code and getting to the different implementations and understanding what they are capable of adding to their various apps. So there's definitely more work to do on conversations with Nostr people.
So there's a thing called frost, which gets into the whole rotation and replication sort of topic. There's also a derivation of that called froster, which addresses the Nostr key rotation topic. I think it's got a lot of work to be done to really make it usable, but just wanted to mention in that there are efforts to kind of address some of these shortcomings.
Go ahead.
The challenge of the lost key is addressed by Frost. You can basically have one-on-one users out there that, when you're not around, can actively react to a simple rotation of the key. The problem more is when, your social network falls apart, you need a backup or whatever. There's no proven way to basically reestablish new keys where the compromise of the old keys is invalidated. So the compromise cases are not solved by that. There really does need to be some kind of rotation of that supports the compromise. So, why don't you ask people how many people are still only keeping a copy of their seat on paper?
The camera's not pointed at you.
Informal poll. How many people? Okay, so there are 2 people doing on paper. How many people just have it on steel someplace? Your seat works. Probably a large number of people. When was the last time you actually checked to see if those C words worked and you didn't do a typo? No.
Yeah, well, that's a hard question. That's a hard question to answer. By the way, for the record, I would say about 20% of people answered to both those questions.
So we have to find it all. So if we're going to have, we're power users, we're deeply involved in Bitcoin, and we are not doing basic processes. I did a study that, you can go to smartcustody.com. It takes about an hour to do it, and I can't get
Are we recording? Okay. We are recording. So to summarize that, I think the point was that from an information security point of view, there's more going on than just whether it works for you right now. There's other aspects of redundancy and disaster recovery that you want to be planning for. And if I'm summarizing correctly, if I could get a nod, this is you want to systematize a bit more in order to achieve those other aspects. Well, I think this is really part of the challenge to building a web of trust is convincing yourself and others that it's worth your time and energy. And if you look around, Coinbase has tens of millions of customers. These people don't believe that they need to, well, that doesn't tell us how many of them also maintain their own keys, but in general, I think most Coinbase customers do not. So it's a huge sign that people don't believe that self-custody is a necessary step. You know, they're not here at slide 3. They didn't get here yet. And getting to slide 3 was a path that took me a while. I had to lose some Bitcoins in order to get there. And I did. That's right. It has to be as easy as setting up the newest chat app. It has to be that easy. It has to be not a trade-off and not something painful. And when it is, then it'll start working. Thank you. Yeah. I think that's right. I think, you know, one of the good things about what we're doing is that we are using a standard. It's a standard that has gone through the W3C process. The BTCR2 aspect of it is not endorsed or standardized by the W3C, but the larger decentralized identifier ecosystem is, you know, at an abstract level, it's the idea of putting a URL on standardized methods for how to understand, how to get key material and endpoints associated with revisions to a DID document. So it's getting there, and I think the great apps are going to go through security reviews to take it to that level and communicate with people what these options are. All right, I believe that's the end of my time. Thank you, everyone.